Hello everybody, and welcome to my talk on CVE-2020-13379. Just to give you a little bit of a roadmap of where we're going with this talk, we've got a short introduction to who I am and what the CVE is about, the discovery, exploitation, and then bug bounty interactions regarding this specific vulnerability. So let's get started. My name is Justin Gardner, also known as Rhino Raider. I'm a full-time bug bounty hunter on HackerOne and BugCrowd mostly. I was previously a penetration tester for Centercom, and my focus within security is on web apps, automated recon, and zero-day hunting. I'm currently living in Yokohama, Japan, with my wife, Mariah. About the vuln, CVE-2020-13379, as I like to call it, this is a fully unauthed Grafana full-read SSRF affecting Grafana versions 3.0.1 to 7. And it occurred because of some URL parameter smuggling and an open redirect chain. So let's get started into the discovery. So before we go deep into the discovery, I wanted to talk a little bit about my methodology approaching open source source code analysis. This is not like a super well fleshed out methodology. It's more of like a base for anyone who wants to get started to base off of, or maybe something for more seasoned source code analysis people to integrate into their own methodology. So the first thing I like to do when I'm approaching a code base is define whether I'm looking for unauthed vulnerabilities specifically or both. In the scope of bug bounty, a lot of times you're looking for unauthed vulnerabilities because that's going to increase the impact the most. And so I like to get that in my head. And from there, I like to enumerate the attack surface with specifically pertaining to unauthed vulnerabilities. So I start with open ports that this specific application would expose. I break it down into the app segments, so looking at like where the reverse proxies are happening and where those reverse proxies are pointing back to internal APIs, figuring out where the source code is for that API, and just kind of getting a good bearing on where we're at, and then diving down further into the routes, specifically focusing on the unauthenticated routes. Now, if you hit a dead end on the unauthenticated routes, can't find anything, that's when I would move towards the authenticated routes and seeing if I can make anything authenticated, unauthenticated, but first I like to focus on unauth routes. So at that point, then you're just mostly looking at the code, tracing user input where it goes throughout the application, and then doing what I like to call sniffing for blood, which is looking for areas in the application that look particularly sketchy. For example, on the right-hand side here, we see the first two juicy looking, albeit, routes in Grafana's source code both require sign-in, and then the avatar service, which is what we'll be exploiting later, does not require sign-in. Later in that code base, you'll see some code that should give you a little bit of a sniff of blood there. So, but we'll jump into that in just a second. So before we dive into like the deep details of the bug, I set up these Docker commands really easy for you to spin up your own instance of Grafana on your own machine. This will allow you to get a vulnerable version and kind of follow along as we're exploiting. So yeah, put that paste bin underneath there in your browser, and you'll have the commands underneath there. That's capital B, capital C, MCE 18J. All right, hopefully you're quick typers. Let's get started. So identifying the vuln. So obviously I'm looking at the Grafana source code here. This is easily available on GitHub. It looks like my camera sort of cut it off a little bit there, but it's going to be github.com/Grafana/Grafana. And in the paste bin, I also put a link to a specific commit hash, which will allow you to look at the unpatched code, since this has since been patched on more recent versions of Grafana. So looking at the API, I was going through all of these different individual routes. And one of the things that caught my eye is /avatar/hash. This caught my eye specifically because it has cache server in it, and there's a lot of funky stuff that happens with caching. So I figured I'd take a look at this. So I started looking for where avatar cache server .handler was in the code. So we're sniffing around trying to find anything that looks sketchy. Looking at the handler function, we can see that it takes the hash from the user path. So it extracts that out of the path, checks to see if that is in the hash or in the cache on line 81, and then if it isn't in the cache, it go ahead and fetches it on line 90 with the avatar.update function. So let's go look at the avatar.update function. Avatar.update then takes that hash that we passed in via the URL, concatenates it with a constant Gravatar source, which is secure.gravatar.com/avatar, and then passes it to a function called goFetch. So now your hacker bells should be going off in your head saying, unauthenticated, taking user input, concatenating it with a server-side HTTP request. This has got everything we would need for a really awesome unauthenticated SSRF. So at this point, I'm pretty excited. I'm buckling my seatbelt. I'm getting ready to do some deep diving into this code. So just the fetch function, goFetch ends up calling fetch, and then here's where it ends up, where it uses Go's HTTP library to make a request to the Gravatar source. Great. So let's break down exactly how we ended up exploiting this. So for this full diagram, I've created a little bit of a step-by-step diagram, so we're going to go through this here. So the attacker sends the unauthenticated request to Gravatar for /avatar/test. On the back end, it extracts the hash, in this scenario, test. It assumes that the hash is the last line on the path, and sends that to secure.gravatar under /avatar/test right here. And then since test does not exist as a hash in Gravatar, it returns back a generic image, and the generic image goes back to us. Not as interesting as it could be. So, but it's a good start. So what we're seeing is user input being taken and concatenated with an HTTP request on the server side. Awesome. So first things that should go off in your head as an attacker is path traversal. And then, being able to traverse back up above Avatar and be able to access something beyond that. And then also URL parameter injection. And I'll show you which one of those I use in just a second. So going back, and then, the whole point of this also would be, just to be clear, is to find an open redirect somewhere in here that allows us to point this server-side HTTP request wherever we want. And that will result in a blind SSRF, at least, depending on the code, a full SSRF. Excuse me. So let's see what happens here. So going back to the code, this is the vulnerable piece right here where it takes the hash. And so using this, I start looking around for open redirects. So I throw secure.gravatar.com into GAO, an awesome tool by Corbin. And I start seeing this D parameter all over the place, which a lot of you got to when trying to reverse it, so good job. So what is that? So we look at the Gravatar documentation, and we can see that D stands for the default parameter. And that allows you to supply a default image that should be displayed in the case that the hash that's provided to Gravatar is invalid. So that's cool. So let's see if we can try to smuggle in the D parameter to this request. Oh, and then, before I did that, I was poking around with it, and you can see right here, secure.gravatar.com/avatar/bad, so that's an invalid hash, /D anything here, redirects to i0.wp.com/anything here. So we've just widened our attack surface there. Now we are looking at more attack surface than we were before, which is awesome. That should excite you. So looking at this, we've got, let me just get my timer here working. We've got the full flow here. So we were able to smuggle in these parameters right here. You can see the %3f and then the %3d. Those decode to a question mark and an equal sign respectively. That is able to be successfully smuggled into the backend request, which then redirects to wp.com/test. So you can see the backend request over here in this little area. So great. So we're expanding our attack surface. We're getting a little further here. So here's the image with going to wp.com, returning a bad request, and then we get the response back as the attacker. So what do? We run gal again on this i0.wp.com. And while we're kind of messing around with the results of that, we come across this bezos.jpg file. And this file is located under wordpress.com/1.bp.blogspot.com. And this does something a little funky. It seems like WordPress wanted to offload the load of any images coming from Blogspot to Blogspot itself. So what it does is it just issues a redirect to Blogspot under that specific path, and we get this lovely picture of a laughing Bezos, but we get an extended attack surface. So I don't think I put it in a slide anywhere, but you can delete anything after .com, and it will still redirect to 1.bp.blogspot.com. So now we've expanded our attack surface to 1.bp.blogspot.com. So what do we do then? Well, we go and look for an open redirect on 1.bp.blogspot.com, but we don't find anything. So that kind of sucks. So I'm kind of sitting back. I'm thinking, what should I do right now? I can only get to bp.blogspot.com, and that doesn't really help us a lot. So then I go back and I start looking at the i.0.wp.com again, and looking at this 1.bp.blogspot.com, and this is the part that tricked up a lot of you guys. So get ready for it. It's coming. And trying to fiddle around with it a little bit. We can do any subdomain under bp.blogspot.com, so I was playing around with that a little bit. And then what happened was I ended up issuing a request with a URL encoded special character in the request, a question mark, which broke the regex and allowed us to get to any host that we needed to supply. That was the open redirect that we needed. So then I started dancing like Oscar, and I ran downstairs and fell down the stairs and told Mariah about it, and I was looking like this guy right here, and I was super excited. So after the excitement, I still got it in my chest. After the excitement of that wore off, I was able to go back and look at the original full chain and put everything together to craft the full response SSRF, which was lit. So here's the final full flow. The attacker sends the request to Grafana with the URL encoded parameters. That results in the vuln Grafana instance issuing the following backend request, which will redirect to redirect.rhineradio.com. We got some fancy URL encoded special characters in there, our special string 1.bp.blogspot.com, and then our super nice juicy target of 169.254.169.254. That gets redirected from Gravatar to WordPress to my attacker-controlled server, redirect.rhineradio.com, where I've hosted a little bit of an exploit kit for this, which we'll talk about later. And then finally redirects over to 169.254.169.254, grabs the juicy AWS metadata that we all love to see, and drops that back in the 200 response code. So, final exploit. Buckle your seatbelts, get ready to go. Boom, there it is. We've got a lot of URL encoded junk in there. We got triple URL encoding. We got double URL encoding. We got normal URL encoding. But yeah, get your screenshots ready, guys, because that's the final payload. Take it, spray it across every program. Let me know if you find anything, because I thought we cleaned it up pretty good, but I could be wrong about that. All right, so oh yes, so by the time this video airs, there will be a blog post up on my blog, rhineradio.github.io. If it is not up right now, which it should be, if my cron tabs work properly, then it will be up tomorrow. This is likely airing in the middle of the night for me in Japan. So if I wake up and the blog post isn't there, then I will release it as soon as I wake up. So yeah, definitely check that out. In that same blog post, I will be releasing a exploit kit for this specific vulnerability. In some versions of Grafana, it seems there are some bad characters that you've got to deal with, so I just coded up some little PHP code that allows us to exploit this properly. And excuse me, I'm trying to drink some water and it's making me burp. You'll see that we can actually, here, let me go back really quick and look at this final exploit. So right here, the percent encoded /225 2F, that's where we put the target afterwards. And this is because I've got some specific code on redirect.rhinoradiо.com that is redirecting directly to anything that follows the bp.blogspot.com. So that will allow you to just specify the path that you want in the actual exploit, and you don't have to go modify anything on the server side each time you try to exploit it. So if you don't want to use my lovely redirect.rhinoradiо.com, which I totally understand, you can host your own version of it and pop some SSRFs with that. All right, wow, we're doing good on time, so I can slow down a little bit. The next section that we're going to go into is just straight up exploitation of this vulnerability. So we're going to talk about how I exploited this on the external network and how I exploited this on, or how it may be exploited on an internal network as a member of a bug chain, which I think is really, really exciting. So I think you guys are going to like that piece. So let's jump into this. So in the external exploitation slide, set of slides, we're going to discuss how we exploited this on the external network or the DMZ. We're going to give you 3 internal pivots that you can do, which will increase impact. And then we're also going to give you some additional software affected by this so that you can add those to your routes as well when you're mass scanning for this or looking to exploit this on a target. So here's the first pivot, the good old AWS cloud metadata that we all love, we all know and love. Just my heart gets beaten just seeing those numbers on the screen. Just to give a nice concise little summary of this, we've got 169.254/metadata, and then we go on to hit the security credentials with the role name. So that's the standard one, that's the one that a lot of people use. In order for this to be in the AWS metadata, the instance had to be launched with IAM creds. It's not always there, it's there like 90% of the time at least, so definitely always hit that one. Also though, don't just go straight for the security creds, also hit /latest/user data. That will contain a lot of like startup scripts and data that is relevant to that machine. So a lot of times you'll find like kube auth stuff in there, you'll find secret keys, sometimes you'll even find even more impactful IAM credentials than what is in this IAM credentials /security IAM/security credentials/role. And then a lot of you guys have probably seen this metadata identity credentials portion of the AWS metadata and not really known what it does. They're a funky set of credentials. Because I had so many of these SSRFs and I was really trying to find good impact, I spent a decent amount of time researching into that. So there will actually be a blog post up on my blog about the AWS metadata identity credentials. You can't do a ton with them, but you can do some things with them depending on how the client has configured their environment. I can give a little bit of an intro into that now since we are actually doing pretty good on time. But essentially these credentials are used by the EC2 Connect service that allows you to SSH into your machines from the AWS panel in the browser. And it has some specific credentials or some specific functions that are used in that sort of interaction. So you can get access to those functions, which can be useful for mostly providing a way to deny access to the box for the other side, the good guys. And it can also, from what I can see, have access to any permission that is globally given to any users in the AWS sub-organization or organization. And so that can sometimes, the ones that I've seen have been able to leak password policy information, and even sometimes if a thing is really weirdly configured, you can get access to user data. So that's definitely something to keep in mind, especially if there's nothing in the user data, there's nothing in the security credentials. You may have sort of a fallback in the identity credentials. Gonna grab some water. All right. Oh yeah, and then here's a little screenshot beneath it as well that just kind of shows you how to use the keys that you pull from this, because I've heard that some people don't know how to do this. So you take the access key that you you generated from, or you got from the SSRF. You take the secret key and the session token that all got returned from the response to /security credentials or to EC2 instance security credentials, and you plug those into the AWS command line tool via environmental variables. And then you call the AWS STS get caller identity function to confirm that you've been able to successfully log in with those credentials. So that just kind of gets you started, and then from there you can use the various AWS command line functions to enumerate your S3 buckets, your EC2 instances, anything else that could be of interest to you. Let's go ahead and move on to the next slide. So the next one is actually pretty cool. In a lot of Grafana instances, there's an internal image renderer running on the internal host. So what you can do on the internal NIC, I guess I should say, is what you can do is actually hit that internal service, and you can pass it a URL to your own domain, and it will open that URL up in a headless browser in the network. And if you all should know that is really bad from Nahum Sek's talk on PDF rendering injection goodness. So definitely go check out that talk if you haven't seen it already. Maybe some of you guys can throw it down in the comments as this video is airing. But yeah, so there's a lot of stuff you can do with this, specifically because this request, actually I don't have it in here, but it also allows you to specify a timeout parameter. So you can essentially just spawn like a JS shell inside of that headless Chrome instance, and then send a bunch of requests out, which would be super useful for spraying the internal network for one-shot RCEs. So definitely keep this in mind when you're pivoting. I think it's normally on port 3001, but it can be on all sorts of different ports. So do your port scans. If you run into this, awesome, hit /render, pass it in, some good stuff. I do have a little demo really quickly I can do for you here. So here we are. Essentially what I'm doing here is I'm just catting the function to show you what page I'm passing into the renderer for you to see. It's going to issue a post request. I'm starting up the Grafana image renderer in a Docker container, and then I'm going to start my netcat listener, and I'll go ahead and pass this HTML file to the render on the local host, and you'll see that I'll get a post request here in the response, which contains a JSON body. You can set arbitrary headers. You can use any HTTP verb if you use fetch no cores and stuff like that. It'll all be blind, but it'll be, like I said, it's really useful for spraying a bunch of stuff into the internal network. So that's a cool one. Let me go ahead and get back to my present. Definitely be on the lookout for that. And before we go into the third pivot, we've got to talk a little bit about other software affected. So just going to give a shout out right now to Nafi and to Rohan for contributing these. Apparently GitLab runs Grafana by default under //Grafana. So all GitLabs prior to X version are also vulnerable to this vulnerability. So add that path to your spray list. There's some really interesting stuff we can do with the pivots on GitLab. So we'll talk about that in just a second. And then also SourceGraph does the same thing. Unfortunately, SourceGraph has it authenticated, unlike GitLab. So if you ever find yourself inside of an organization's SourceGraph, then you've got an SSRF. But if you find yourself inside of an organization's SourceGraph, they might be in trouble anyway. Yeah, and if you guys know of any other software that we can use, great. I would love to add those to the blog post. All right, so speeding up a little bit again here. The next pivot is the GitLab Prometheus Redis exporter. A lot of times in GitLab, for monitoring purposes, they'll have these sort of exporters where you can see the contents of various different services. So there's a Postgres one, there's a Redis one, there's a bunch of other different ones. So I was playing around with this with Corbinek and TechnoGeek, and we found that if you hit, normally it runs on 91.21/scrape, and you pass in a target, you can actually specify a Redis instance. And what'll happen if you put check keys equals to star is it'll go out to that Redis instance, dump all of the keys, and then return that to you in the HTTP response. So you can do some really cool stuff with this if you know some internal Redises in their network, or even if GitLab is running a Redis that has something sensitive in it, you can hit that as well. I'd imagine this would work for a lot of the other exporters too. Like I mentioned, there's like a Postgres one and some other ones, so definitely check those out if you're ever in this situation. All right, so now internal exploitation. This is going to be awesome. So you can use CVE-2020-13379 to escalate your other vulnerabilities. So one of the most common types. Oh wait, hold on. I'll go through this first. So this SSRF has a unique feature, and that's its content type. So if we go back to the code, we can see that after the avatar update call, it does this really weird thing on line 104. It sets the content type of the response to image JPEG. So what you're actually doing here is you're getting real SSRF response back in the content type of image JPEG, which is great because one of the most common types of blind SSRFs out there is just an image-only SSRF. So if you've got an external image-only SSRF, you can take that, point it at the target's internal Grafana instance, exploit this vulnerability, have the internal Grafana instance hit your other internal target that you want, return the content type or return the content from that SSRF in the image JPEG type, and then have that returned back to your external image-only SSRF, and boom, you've got a full read internal SSRF. That's a huge escalation. So definitely be on the lookout for Grafana instances in your target's internal network, and if you can hit one, you might be getting your escalation to of a blind SSRF to a full read SSRF. All right, doing good on time. We're in the bug bounty section now. We're going to talk about some mass exploitation, what it looked like to exploit this vulnerability, and some collaboration. All right, boom. So there are the reports. There were 25 plus crits, 15 plus highs. A lot of them resolved, as you can see here. Mass exploitation. I show you this for the purpose of several things. Collaborate with your friends and have mass exploitation software that you can use to spray your 0 days, because it's awesome. I'm not going to give actual numbers out for how much I made off this vulnerability, but I'll give some relative numbers to encourage you to hunt for 0 days. The first one was that 67% or 68% of my 2019 earnings, that's equivalent to the earnings that I made from CVE 2020 Elite 9. And 78% of this year's earnings year to date, I started going full time this year, so it's a little bit more than last year, were from these CVE bounties. And then lastly, all of my bounties in total, as a top 100 hacker on HackerOne, 23% came from this bug. So if you hunt for 0 days, you can really make some good cash off this. So I would really recommend looking into it. Yeah, takeaways. 0 day hunting can be quite lucrative. Do it. There's a little bit of tension in the community, some of you might have seen, about hunting for 0 days. There are some programs who won't pay for it, and that's fair. That's their stance. That's okay. But if you know that the target accepts them, which a lot of them will, because they want to tighten up their perimeter, you can make a lot of cash off of them. And so the other takeaway would be to have a reconnaissance system to help mass exploit, and then once you're done with your own exploitation, hand it off to a friend who will split bounties with you. I recommend Today's New and Ben. Both of them very fair bounty splits, very kind, very trustworthy, and particularly Today's New has access to just an insane amount of programs, so check that out. Have a report templating system to help you save time writing reports. I released one at github.com/rhinerator/reports. And then also have a canned response for your Twitter DMs, because if you have your DMs open, because you're going to get an influx for sure. Here's my collaboration slide. Shout out to Eric, Ben, Nafi, and Streak for all of the wonderful collaboration that we've had. Shout out to the CVE reversers. Good old Corbin was number one, who kept their mouth shut about the bug until this video dropped. And also shout out to Ricardo for donating some of the bounties he got from the CVE to some children in need in Brazil. And that's the end of my presentation. So thank you all so much for watching. If you have any questions, you can reach out to me on Twitter under Rhinerator, or you can shoot me an email, which I've left in this final slide. Thanks.